Hi everyone, this is our last unit of chemistry. We made it through such a weird year. But the good news is this is all we're doing. So we're not going to do a final. I think I told you that before. Maybe I didn't. Maybe I just told a few people that I had asked. So we're basically just need to finish off this unit and then we're done. It is going to take most of the time because it's a little bit different than anything we've done so far. And we're gonna just take it slow because I know you guys are kind of over it. So we'll just have like a little bit to do each day and call it a year. All right, so let's get started. Okay, so, all right, so organic chemistry is the study of all carbon-based compounds. So carbon has its own class in college. It's 2 years of, or it's 2 semesters of organic chemistry, and then you would take like a semester or 2 of inorganic chemistry, which is basically everything else. Okay, so carbon has 4 valence electrons. And remember, when things bond, they want a total of 8 to make a stable octet. So that means carbon can have up to 4 single bonds, or it can have combinations of single, double, and triple bonds. So if it has a triple bond, it would also need a single bond because you need 4 bonds. Okay. Many hydrocarbons, so hydrocarbons, those are compounds with hydrogen and carbon, are derived from petroleum deposits, which are found in the ground. So for example, octane, it was found in petroleum and then sent to a refinery and then came out as octane. It can exist in long chains, rings, or networks. So this is a long chain, octane. This is a ring, 2 rings actually, this is caffeine. Or it can be like a network solid like carbon or diamonds. Okay. It makes covalent compounds when bonding with hydrogen and other nonmetals, and the shapes are all derived from tetrahedrals. So remember, a tetrahedral is when you have kind of 4 things combined with a central atom. So since carbon has 4 bonding sites, it all comes from that shape, the tetrahedral shape. Okay, moving right along. Okay, the distribution of charge is symmetric. So they are non-polar molecules in general. So usually you have like a long chain of carbons. Those are non-polar. You might have some things with different functional groups that make them polar, but we'll talk about that later. Non-polar molecules are attracted to one another through van der Waals forces. This is like review. Melting points are generally low, which increase as size increases. So as your chain of carbons increases, so does your melting point. And these are typically non-electrolytes, which mean they don't conduct electricity and they don't split into ions unless it has the functional group COOH, which indicates it's an organic acid. Okay, so those are some very basic characteristics of organic molecules. All right, so the next part is organic prefixes, and I believe this is table P in your reference table. Okay, so the number of carbons indicates the prefix. So it's going to have a totally different naming system based on how many carbons you have and the type of bonding you have. So in your reference table, I think it goes to 5 maybe. But it's convenient to kind of memorize these so you don't have to go back and forth. So if you have 1 carbon, the prefix, and remember prefixes come before the endings, is meth, 2 eth, 3 prop, 4 is bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 known, and 10 dec. So I always say Marvin eats peanut butter to help me remember the first 4 prefixes, because I think 5 through 10 are a bit easier because you've seen them before in math class. So meth, eth, prop, bute. So Marvin needs peanut butter. So I would just say that over and over and over in my head to help me remember, but you can come up with your own if you don't like that. Okay. Okay, so I want you to take a minute and see if you can either write the prefix or the number of carbons. Okay, so pause it, do that, come back, unpause it. So eth, prop, meth, Marvin, 1, bute, 4, pent is 5, hept is 7, non is 9, we have oct, dec, hex, 6. Okay. Next up, alkanes. Okay, so this is table Q. So the homologous series of hydrocarbons is table Q. So this is going to give you information about alkanes, alkenes, and alkynes. So if you open up to table Q, you will see some of this information there. So they are only single bonds, meaning they are saturated. So when the carbon is full with 4 single bonds, it is considered saturated. So I always think single saturated. The general formula is CnH2n plus 2. So what that means is, let's say we have 100 carbons. If I wanted to figure out the number of hydrogens, I would multiply that 100 by 2, so 2 times 100, 200, and then add 2, 202. So you can do that with anything to figure out the molecular formula. So the molecular formula is just the simple formula with the atoms and how many you have. So for example, in number 1 carbon, if I plug in 1 carbon to this formula, I would do 2 times 1 is 2 plus 2 is 4. So CH4. So I could do it that way, or I'm just going to draw them out and then figure it out. Okay, so also alkanes are nonpolar and have low melting points. So label the high and low melting points on this chart. Low melting points at 1 carbon, and then it gets higher as you go down to, I believe, 5. High melting point here. Okay, so let's begin. Prefix plus ane will give you the name of any alkane. So the prefix, remember, comes from how many you have, and then you add ane because it's an alkane, okay? So prefix 1 is meth, and then you add ane. So that's the name of this compound. Structural formula, so I write C, and then remember that each C needs to have 4 bonds. So these are hydrocarbons, so the other bonds that aren't C are going to be H's. So I'm just going to write a single bond, 1, 2, 3, 4. So that's my structural formula. The condensed formula is going to be the same as the molecular formula for this one only. But basically what you do is you look at the first carbon, we only have one carbon, and then you say how many H's are attached, or say whatever else is attached. So it's CH4. Okay, so let's do that for the second one. We have 2 carbons, so 2 carbons is F. I'm doing alkanes, so the ending has to be ANE. So when you're drawing your picture, we begin with 2 carbons. And since it's an alkane, they have only single bonds. That's super important. Okay, so there's my single bond. Now I need to figure out how many hydrogens I have or need. So this carbon, carbon 1, you don't have to write the 1, has 1 bond. It needs 4. So that means I need to add 3 bonds. And those 3 bonds are going to be hydrogen. On the second carbon here, I have 1 bond. So that means I need to add 3 more bonds. H, H, H. Okay, so the condensed formula then is you're just going to follow along. So in the first carbon, what is it attached to? It's attached to 3 H's. So I would write CH3. In the second carbon, I would write CH3. So basically you're just using the carbons and writing what it's attached to. And then the molecular formula is adding it all together. So C2H6. So in your homework on Wednesday, there's going to be questions about the structural formula, the condensed formula, and the molecular formula. In addition, there will be questions on the skeletal formula, which we're not going to talk about really, but this would be a skeletal formula for 3 carbon chain. Okay. So you can either try to do the last 3 by yourself, or you can do the next one with me, try the last 2, whatever. Okay, so I'm just going to go right through. You can skip to the end if you don't need any explanations. Okay, so 3 carbon chain begins with the prefix prop. Since it's an alkane, it ends in A and E. Structural formula: 3 carbons, single bonds because it's an alkane. So now I need to figure out how many, you should probably do this one with me, how many hydrogens are attached. So in the first carbon, I only have 1 bond. So that means I need 3 hydrogens. H, H, H. In the second carbon, I have 2 bonds. So I need a total of 4. So that means I need 2 more H's. H, H. And then the last carbon, I have 1 bond. So I need 3 hydrogens. Okay. So then condensed formula, I'm going to start with my first carbon, C, and write how many things it's attached to. 1, 2, 3 H's. So CH3. And my second carbon here, I'm going to write how many H's I'm attached to. H2. And then my last carbon, 3 H's. So this is the condensed formula. Molecular formula, C3H8. Okay. Next one. 4 is bute. A and E for single bonds. So 1, 2, 3, 4. Okay, so now I'm going to give you a shortcut. So when you're drawing your H's, organic chemists get a little bit lazy, and so instead of drawing H's, actually writing the H's in, they just draw these lines, and then at the end of the line, it's assumed that you have an H. So in this carbon, you have 1. So I can just write 3 lines, and it means you have an H at the end. You can draw the H's or you can just draw the lines. It does not matter to me either way. And the next one needs 2 because I have 1, 2, 3, 4 bonds now. 1, 2, 3, 4, 1, 2, 3, 4. Okay, so condensed formula, CH3 on the first, CH2, CH2, CH3 on the last one, and this would be C4H10. And then the last one is pentane, pent for 5, A and E for single bonds. 1, 2, 3, 4, 5. And then you're just going to add your H's. This has 1 single bond, so it needs 1, 2, 3. This has 2, so it needs 2. Has 2, needs 2. Has 2, needs 2. Has 1, needs 3. Okay, so this one is CH3, CH2, 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 CH3. You could probably do this also, CH3, CH2, and there's 3 of them, CH3, but I don't know. I think it's easier to just do it all out. C5, H12. Okay, so pause the video, flip to the top of page 3, and see if you can write the name and the formula for the last 5. So as a reminder, the formula follows this format, CnH2n plus 2. So you can, however many carbons you have, just plug it in for N. Okay, so pause the video, do that now. And then when you come back, we'll just do the answers. Okay, so 6 is hexane, 7 heptane, 8 octane, 9 nonane, 10 decane. Okay, and then the formula, so I would have C6, H, 2 times 6 is 12, plus 2 is 14. C7, 7 times 2 is 14, plus 2, 16. 8, 8 times 2, 16 plus 2 is 18, so you should see a pattern. 14, 16, 18. So this is C9H20 and then C10H22. Okay, so that's where we're going to stop today. Hope you guys have had a great day. Miss seeing your faces, and we'll talk soon.